Graph each of the following compound inequalities on a number line. Now, first of all, in number 1, let's discuss what this symbol means. This symbol is what we call the intersection symbol. It means we want the intersection of these two sets. Another way of translating this would be with the word AND. We want to graph all of the values of x that are both less than -2 and greater than or equal to -4. Let me start by just marking 2 and -4 on the number line. If we want the values of x that are both less than 2 and greater than or equal to -4, we would want the numbers in between -4 and 2, because these numbers are both less than 2 and greater than or equal to -4. Since we want the numbers that are greater than or equal to -4, we would make this a closed circle, since that satisfies that inequality. Now, number 2 says x is less than 2 or x is greater than or equal to -4. Again, let me just put down -4 and 0 on the number line. If we want the numbers that are either less than 2 or greater than or equal to -4, that would in fact include every single number on the number line, because we just want the values of x that are one or the other, and any number is either less than 2 or greater than or equal to -4. Number 3 says that x is less than 2 and x is less than -7. I'll put down 2 and -7. And if x has to be both less than 2 and less than -7, that'd really be just the same thing as saying that x has to be less than -7. Because if x is less than -7, it's of course less than 2. We wouldn't want to include the numbers between -7 and 2, however, because these numbers do not satisfy both of these inequalities. Number 4 uses this symbol, which is what we call the union symbol. The union of two sets means you want to take all of the values of x that make either of these equations true. So we can translate this using the word OR. So if I place 2 and -7 on the number line, we want all of the numbers that are either less than 2 or less than -7. That would include all of the numbers to the left of 2. Because all of the numbers to the left of 2 make one or the other of these inequalities true. It doesn't need to make both inequalities true, just one or the other. And all of the numbers to the left of 2 are either less than 2 or less than -7. Number 5, x is less than -7 or x is greater than or equal to -4. Well, -4 and -7 are both to the left of 0 on the number line. If we want the numbers that are either less than -7 or greater than or equal to -4, we just want to graph all of the values of x that make one or the other of these inequalities true, which would include all of the numbers to the left of -4, including -4, since x is greater than or equal to -4, and all the numbers to the left of -7 as well, since these are all the numbers that make one or the other of the inequalities true. Now, for number 6, we want the values of x that are less than -7 and greater than or equal to -4. Well, if we think about this a little bit, we'll come to realize that there are no numbers that make both of these inequalities true, because the numbers that are less than -7 are to the left of -7, and the values of x that are greater than or equal to -4 are to the right of -4. There is no number that makes both of these inequalities true at the same time. So we actually shade nothing on the number line.